Hello everyone and welcome. Today I would like to talk about remove invalid parentheses. I'll be using depth first search and recursion. And here's an example. This question is considered a hard question. It provides you a string S that contains parentheses and letters. It asks you to remove the minimum number of invalid parentheses to make the input string valid. To solve this problem, we'll be using stack. In particular, we'll be using stack to track whether a pair of brackets cancel out each other. Please feel free to look up the other video in my channel to become more familiar on this topic. Now, I will walk you through a solution I developed myself and which is adapted from a Java DFS 3 millisecond solution. For the original Java solution and the URL, please feel free to look up the description section under this video for that URL information. First of all, we will use a tuple as a brackets pair. This tells the computer what character is the opening bracket and what character is the closing bracket. With the pair, now I will introduce two important concepts. First, how can we detect the first unpaired closing bracket? The answer is we may use a stack or simply a stack size counter for that purpose. And this is the code here. Please feel free to pause the video to read this code in some details. And this is an example here. Second, after we identify the first unpaired closing bracket, how can we fix that anomaly? The answer is, as we concern only about increasing stack size from -1 to 0, we may remove any of the closing brackets before or at index I. And this is the code here. Please feel free to pause the video to read the code here for some more details. And we move that code here. However, this code has a potential problem. That is, when we have a series of consecutive closing brackets, removing any of them will lead to the same result. An example as shown here. To solve that problem, we remove only the first one in the series when we have a series of consecutive closing brackets. The solution is shown here. Please feel free to pause the video to read the solution for some details. Importantly, as I highlight it here, if the first one within the removal search range from 0 to index I is already the closing bracket, then we don't need to worry about consecutive closing brackets. We only worry about the consecutive closing brackets when index j is larger than the left end of the search range, and we move that code up here. Now, let's consider the situation after we remove one closing bracket at index j. So first of all, the length of the new string will become the length of the old string minus 1. Next, when we scan the remaining string for anomaly, we want to start at the immediate right of this previous index I, which means index I plus 1, and it's the character A here, for example. However, since we have removed one closing bracket at index j, we will take one step back. So the actual start index for the next anomaly scan will be index I plus 1 minus 1, which equals to index I. And we will pass this along as a variable to the next recursion call. Similarly, When we search for a character to be removed at the next recursion call, we want to start at the immediate right of this previous index j to ensure that the DFS search path is progressing forward and non-overlapping. But since we have removed one character at index j already, that will take us one step back. So the actual start index of the next removal scan will be index j plus 1 minus 1, which equals to index j. And this will be passed along as a variable to the next recursion call as well. That is, at the next recursion call, we will pass along these two variables, anomaly scan start index and removal scan start index. Putting together what we have so far, we have this set of code here. As you can see, this DFS stands for depth first search. Calls itself recursively to scan for the next anomaly and to remove an appropriate character as well. Please feel free to pause this video to read this set of code in some detail. Now we will consider some additional conditions. First of all, what if the stack size is larger than 0? It means there is at least one extra opening bracket that is unpaired. To fix that, we will scan it again from right to left with a reversed pair of brackets. And to reuse our code, we can simply reverse the string and scan from left to right again. Second, what if the stack size is 0? It simply means there's no more anomalies, and we are done. We'll then append the cleanup balance string to the results array. Putting together what we have so far, we can now complete this DFS helper function as the following. Please feel free to pause the video to read the information here in some detail. Now we can also analyze this code for complexity, because its recursive process is to search valid answer and involves a search space using DFS, where each leaf node is one valid answer. It means for time complexity, it will be OM times n, where m is the total number of recursive calls, and n is the number of leaf nodes. And for space complexity, it will be also OM times n, where m is the total levels of recursion stacks, and n is the number of leaf nodes. Here's an example that illustrates the DFS search space for unique valid answers at each leaf node. Let's remove invalid parentheses given the string s as the following. Please feel free to pause the video to read the example here in some detail. Now that we have covered the background, let's write the code. For simplicity, I'm going to copy and paste the DFS function that was developed in the video. So this is the DFS function that was developed in the video. And to use this function, we're going to initialize an empty array as the result array. And then simply call this DFS helper function by passing s as an argument here. And then finally return the results array, and that's it. Now let's submit this and see how it works. We submit, it's pending, and done. With 16 milliseconds, faster than 100% of other submissions, which is pretty good. And that's all for this video. I hope you find this video to be useful. This is a relatively hard question that takes a lot of thought and considerations, but with some practice, you should be able to get a hang of it. Please feel free to subscribe for more videos. and I'm hoping to see you next time soon. Goodbye.